Go. Okay. Okay. Good morning, everyone. Good day, everyone. Uh, Kena, Raleigh. So I'm going to be introducing you guys to the electricity topic. Yeah. So, when ngala motho re ipotsa gore uh, what is this electricity that we are talking about? What is electricity? So you'll get to know that electricity, by definition, rare, electricity is the flow of electrons. Electricity is the flow of electrons. Like so, electricity is the flow of electrons. So, rare, electricity, it is the flow of electrons. A very simple definition. How something is flowing, what is yeah, it's moving. Como la por harre a flow, rubber air. So, electricity is the flow of electrons. Rena electrons are flowing around the circuit. Yeah. So this takes us back to the basics. It's like before we discuss electricity. We discuss the structure of an atom. So the structure of an atom. An atom is like this. So, before we discuss this topic of electricity, ke le ka etsa pele structure of an atom. But I if you take matter and you divide it to the smallest possible pieces, you end up having what we call an atom. And an atom uh, is constituted of three subatomic particles. One of the more the electrons, the electrons that are situated, that are sitting outside the nucleus. Electrons are freely sitting outside the nucleus and they are contained in these things we call shells or energy levels. So within the nucleus we have protons and neutrons. Mo go sonyana mo ke sa kgolalang ke di-neutrons. Mo go ntshonyana mo ke mo reng kwane ke di-protons. So why ke batla gore o itse structure sa atom before re tsena mo topic ya rena ya motlakase ke gore ke batla go appreciate one thing gore an atom is made up of these three subatomic particles being the electrons, protons, and neutrons. Of the three, neutrons and protons, they are locked. But they are locked within the nucleus. They are locked within the nucleus. And, and you only have electrons freely floating outside the nucleus. So, as we go along, ke tla ke go bolelela gore mo exameng di-examiner ga di rata go botsa dipotso tsa mofuta mang. Ga o ka tsamaya nthela tsela yotlhe fela, you will realize that the exam is going to be very easy for you. So, of the three subatomic particles, only electrons are sitting outside the nucleus. The other two are locked within the nucleus. So, only electrons are mobile. Only electrons are free to move. So, of the three subatomic particles, which one which one is able to move? It's electrons. So this one can examine which of the three subatomic particles, which one is able to move or which one is able to flow? Ke electrons. That's why electricity is the flow of electrons. Yeah. Of the three subatomic particles, only electrons are mobile. Only electrons can move. Only electrons can flow. I think I emphasized it more than enough. So you can't disappoint me and get it wrong, no exam. So once na itse ka tsela e jalo, of course you may continue to know gore electrons are massless, they've got a charge of negative one. Protons and neutrons, since they are found within the nucleus, they are called nucleons. Yeah, it's not about each of the following are nucleons. You'll be looking for protons and neutrons. They are nucleons. Residents of the nucleus are called nucleons. Aka batswana mo botswana batho ba nnang mo botswana ba bitswa gote ke batswana. So dilo tse di nnang mo teng ga nucleus di bitswa gote ke di-nucleons. Citizens of the nucleus are called the nucleons. Yeah, so ne batla go reflecta ka the structure of an atom. O kgona go appreciate the fact that electrons are sitting outside the electrons. The electrons are sitting outside the nucleus. Everything else is locked. Electrons are freely floating. They can have that freedom to flow. So after now is electrons are the only subatomic particle that are able to flow. Merely electricity is the flow of electrons. What is pushing these electrons to flow around the circuit? What is pushing electrons to flow around the circuit? Yeah. Um, Go na le potso e batho ba rata go e botsang, o tla ba go botsa gore ha e le koko le le go tlileng pele. So e tshepe ke batla ka se go ntse ka tseleng tsalo gore o itse gore go tlileng gore go nne le motlakase gore these electrons to start flowing around the circuit go tlileng pele. So the very first thing you need to have before you can have electricity, before you can have electrons flowing around the circuit, you need to have what you call potential difference. So parameter we discussing the potential difference. What do you mean by potential difference? Your level is responsible for electrons flowing around the circuit. Potential difference. We have potential difference in the difference between the electric status between 2 points. We have only two charges. No one will ask you this question, I'm just giving you an illustration about how to think of a potential difference. A point it is positively charged. Another point it is negatively charged. These 2 points are electrically different. They are electrically different. So the difference. This one is negatively charged. This one is positively charged. So that difference is what we call the potential difference. So I have an illustration. If this was a positive one, if this charge had a positive one, charge I can find a negative one. We don't know what is the difference between plus one and negative one. However, a plus one difference I can have the difference without we subtract. Yeah, difference we subtract. Sum without you add. Product they were multiply. Yeah. So the difference over a plus one difference minus negative one minus and positive. So and plus one equals to 2. So the difference between these 2 points is 2. So the difference between these 2 points is 2 volts. We measure the difference in volts. So one thing you'll see in this topic is full of abbreviations. Potential difference PD. The other name for potential difference is voltage. re mo abbreviate ka V, and gotlhe potential difference voltage re di measure ka mo go teng ke di-volts. Re measure potential difference kana voltage ka mo re ke di-volts ra abbreviate ka V. Mm. So it doesn't mean anything other than the difference between the positive terminal and the negative terminal, the positive point and the negative point. Yeah. So the difference actually we measure in volts. I got another example. I'm going to another example. Say we have a group of protons here. Say we have a group of protons here. And I remember positivity of number. We can have positivity of number plus 10 plus 10. Really positive charge of plus 10. We are a group of electrons here. We are a group of electrons here. Better negativity about 10 electrons here. We have negativity in negative 10. Mm. Negative 10. So raise the word. Unlike charges attract. How to say this more with or unlike charges attract. Like charges repel. Either positively positive they repel. Negatively negative they repel. But positively negative they attract. So the attraction that takes place between these 2 points, the attraction can be measured. You measure ka one more you want to potential difference. So you measure ka means what is going to give volts. So what is the difference between positive 10 and negative 10? Our 10, positive 10 of difference again minus negative 10. So minus dira plus. And now 10 plus 10 and not 20. So the difference between 10, the difference between positive 10 and negative 10 and not 20 volts. So make do some illustration here so that you get an idea of what really the potential difference is. It's the difference between the positive side and the negative side. Yeah, so you measure that difference, you calculate that difference, and the difference becomes your potential difference, yeah, or the voltage. It is measured in volts. Yeah. So I think by now we'll have an idea for what exactly is the potential difference. Potential difference is something that we can measure. We can measure this using an instrument called a voltmeter. We can measure potential difference using an instrument called a voltmeter. It is the volts. So, on to begin electricity, we are going to discuss all these 5 parameters. Well, every time I'll emphasize which parameter is measured, which one is calculated. As for the voltage, it is measured. There's an instrument that measures the voltage. The voltmeter. Mm. And then the other thing you should know, um, um, there are sources of this voltage. For you, for a second, you need the sources of the voltage. The first thing that you need, I can give a kukulele, or in highly kukulele, what a kukupili, kukuku yela money. How can I live again? So, what I want to you need voltage. That's the genesis of electricity. So potential difference ko ne what I need right. That's the difference of having that positive point and the negative point. When the level is going to drive everything more thing. I know what happened in the Yeah. So the sources, before we can explain about how, what are the sources of this potential difference you're talking about? Now let's say in 1.5 volts, yeah, is the source of power. Yeah, the sources of voltage and the regular sources of power. More regular like a bit say is a source is a source of power. Rally car battery. Battery are say 1.5 volts. Kuna the battery we don't have a cuboid that is 10 volts, but kuna the reach ya ready ya koloi ya 12 volts. then voltage ya motlakase wa ko ntlong ke 240 volts. So those are the common sources of power that we are used to in our lifestyle. Yeah. So at the point of this voltage, how does it bring about? How does it bring about this flow of electron? So we can never discuss this topic of electricity. That's a chance more like when I say this arrangement is funny. The more rangy this diagram, the more rangy is a second. This thing tomorrow when it's a second. A circuit rely in arrangement of a cell. This is our power source. It's a cell. More than the connecting wires or the conductors. Because already electricity, electrons can only flow through conductors. And more in this switch more the bulb, our appliance. So this is what happens. How the mela bit the home I'm saying line e or tobane e representa positive. E is super positive. E kgutshwane e rela gore is the negative side. So se se when this is the source of the potential difference. When you have this potential difference, you have simply a point of positivity and a point of negativity. And as I've already told you, positive and negative, unlike charges, do what they attract. So there's going to be an attraction between this positive side and the negative side. That attraction, a potential difference. It's going to drive electrons around the circuit. Electrons they shape from the negative side and then get attracted here the crossover. They have to move around the circuit. The electrons, remember in Kirle of the three subatomic particles, only electrons are able to move. So you have a positively charged side here. You are not going to get electrons, you are not going to get protons flowing around the circuit. No. It's electrons that are mobile. It's only electrons that are able to flow. So they are going to flow around the circuit, being attracted to the positive side. So once we close this switch, once we close the switch, our circuit is on. A circuit on for our electrons get attracted to this point, they start flowing. Our electrons start flowing around the circuit. Our electrons start flowing around the circuit towards the positive point because of that phenomenon of attraction. So offloading electrons from where to where, from the negative side to the positive side. So that flow of electrons equals to again potential difference. This existence of the negative side and the positive side, that attraction is what you call the voltage. It is what is going to force electrons to be attracted from this negative side, being attracted to the positive side, and as a result, electrons starts moving around the circuit. So electrons, because the report I have got why do electrons flow around the circuit? What's pushing electrons to flow around the circuit? Electrons flow because they're being pushed by what? By the potential difference. The potential difference is the gradient. It's the gradient. It provides that slope for for electrons to flow around the circuit. What is the gradient that pushes electrons to flow around the circuit? It is the potential difference or the voltage. So never forget it. And we are simply talking about electrons being attracted from the negative side to the positive side. Yeah. So I think I'm done. I've emphasized voltage enough. And because of that voltage, we have electrons flowing around the circuit. So a group, hardly electrons flowing around the circuit. We are not talking about one or two electrons. We are talking about multitudes, a group of electrons flowing around the circuit. So a group of electrons flowing around the circuit is what we really like a charge. You call them charge. So if you get a group of electrons flowing around the circuit, you call them charge. And that charge is abbreviated as Q. Yeah. Topic the abbreviation means we abbreviate charge as Q, and then this Q is this charge is measured in what we call coulombs. Charge is measured in what we call coulombs, abbreviated as C. So what is charge? Charge, we are simply talking about a group of electrons flowing around the circuit, being pushed around by this voltage. So charge is a group of electrons flowing around the circuit. Yeah, a group of electrons flowing around the circuit is charge. And don't forget at the back of your mind, why are these electrons flowing? They're being pushed by who? Potential difference. So charge flows around the circuit. Potso ba ratang mo exameng ba tla go botsa gore in which direction do these electrons flow? In which direction does charge flow? O tla tlhoko gore charge it flows electrons they are negatively charged. Obviously they will be found at the point of negativity, the negative side. So electrons flow from the negative side or the negative terminal to the positive terminal. So electrons flow from negative to positive. How about water flow of charge? How about water flow of charge? No examine. What will charge flows from negative. Charge flows from negative to positive. So charge flows in the direction of negative to positive. Yeah, you have charge flowing around your circuit being pushed by this potential difference. One thing is what I will see is the charge is the electron, usually by the rate must get there. Yeah, because the right thing must get there. They flow around, they don't just flow around empty handed, they flow around the share energy. Give the number the rate must get there. So how the charge is abbreviated as Q measured in coulombs, and it flows in direction from negative to positive. However, these electrons don't just flow empty-handed. They flow around the circuit carrying what you call energy. Yeah. Charge flows around the circuit carrying energy. Um, um, Energy, different types of energies. What sound energy, what kinetic energy, what chemical potential energy, what gravitational potential energy. So in this topic, how would they calculate the energy? We are referring to electrical energy. How would the work done? How would the electrical work done? Yeah. So work done and energy, same thing. How would the work done? We can work done from abbreviated WD. Energy from abbreviated IE. So same thing. How would the calculate energy? That would the work done. Same thing. Who is carrying energy in the circuit? Energy is carried by electrons. Yeah, energy is carried. So when charge is flowing around the circuit, it doesn't just flow empty-handed. It's a energy. Yeah, you'll realize that most science, either about physics or about chemistry, energy is always related to electrons. Yeah, energy is carried by electrons. Hari ya go bua ka hara go discuss topic ya bo enthalpy, topic ya bo exothermic chemical reactions, bo endothermic reactions. Energy is released from the bonds. As we break the bonds, we use energy. As we form new bonds, we release energy. So we release new energy from forming what bonds. And although we already bonds that we are not for bonds, what makes a bond? A bond is made up of electrons. A bond is made up of electrons. A single bond is made up of 2 electrons. Double bond is made up of 4 electrons. Triple bond is made up of 6 electrons. So energy is always related to electrons. Yeah, higher bonds are electrons. So Energy is carried by electrons or bonds. So let's talk again, like I say, energy is carried by electrons. Don't forget that. And this irritable voltage like a voltmeter. So how am I charging? Charge. We don't. There's no instrument that measures charge. We calculate. We calculate charge. There's a reason I'm telling you what we calculate charge. More you'll get to see why it's all about be. How can we work energy? Energy when it is measured. It is measured. Energy is measured in a unit called joules. Energy is measured in a unit called joules, abbreviated as J. Yeah, yeah. 1,000 joules is a kilojoule. Already, certain appliance of electricity uses an energy of 2,000 joules or 2 kilojoules. We are got the amount of energy that the appliance uses per a certain amount of time. So energy is carried by electrons. Yeah. Mm. Energy, is calories. Yeah, calories. So it's measured in joules. And then the other thing, the other parameter that we are going to discuss is current. Is current. So current, they abbreviate like a I. They abbreviate like a I. And then this current is measured using units called amps. Current is measured in units called amps. Apa ngwe tlo ba re ke amps. Ba abbreviate ya le A. There is an instrument that measures current. That measures current in the ammeter. In the ammeter. Brings 20 amps. So someone might be asking himself or herself, what is this current we are talking about? What is current? So the Bible is one. Current is a wave. It's a wave produced by flowing electrons. Every time there is energy conversion, lo tla dira to be go teng yone conversion at king everything yone energy conversion but re itse goreng re kgona go tsaya dijo re di ja di tla dijo ke chemical potential energy ha re di ja di re fa bothito di produce heat energy mo mebeleng ya rona re kgona go tsaya motlakase ke electrical energy re kgona go tsaya re produce light re tsaya motlakase go convert to light re dirisa bulb re kgona go tsaya motlakase re convert to sound energy re dirisa radio when I was like I said, convert to bothito, we do just stove. So we can convert another one energy into another residence. Yeah, and I need to be getting in full immediately. But one thing I'm trying to communicate with you here, Johorin, hela jaka, how tsamaya go le letsatsi, how tsamaya go le letsatsi. O oka on a sunny day, on a moruti. How oka on a moruti to Barao on a sunny day. Yeah, there'll be a shadow next to you. How kick out how and move to a house. Honey, who got a polo hollow me, ye jambato. Mesa on a whole one hour motor demfo, me on a one muruti. I want a muruti, I eat a whole of a motor demfo. Because I have no one a motor, one I want a muruti. Me I want to move the motor demfo. So, similarly, every time there is energy conversion, on a wave, every time there's energy conversion, when one form of energy is being transferred or being converted into the other form, that process is just a physics phenomenon. Muruti what thing is a wave. So every time we see a wave, what once our energy conversion is taking place. It's like a wave is a shadow. Our energy conversion is taking place. I'll give you an example of waves. Only there is a wave here, right? Now, by the way, discuss a bit ya wave here in full at length. What the economic or the time I get wave you were. So, how can that meet? How can I watch a body means still? I am here. I was a duster ends and away like Halamutin Hamid. I am. I that's a total meeting. Or one minute, not going to be little signing. That's my second. I didn't look at any. Homo that it gives an impression of me. Yeah, Patalani. The second and the John of one define impression of ring, Media Patal. But the truth, your remedy, and I know why. I have up and down, up and down. Wavy go in a patal line. Homo one more is a wave. Who wants more solution with the remedy? So the energy we get so with the kinetic energy, yeah, that moving object deal with the energy get dissipated across the water body. So energy then have partial elements if those waves. So you see a wave because one form of energy is being converted into another form. So that's why you see a wave. So I don't really say I will hold calamity and anxiety still. I would se mo rwang di phone ha o ba le qolobu mme ha o kga ile mo tlhametse a ile di sekala di bolo ga yane I read those riddles o shoko so se wetse mo teng ga metsi le ha o le kwena le mo teng ga o le di phologolo go bona so se wala se metsi wala metsi a tshikinya ga o itse gore so se khumile metsi because one energy is being converted into metsi is being transferred through metsi so that's an example of a wave ke batla le tsena go le kgona go appreciate this a wave ke right. How ka tsaya mogala, for example, o tsaya mogala o fela to the other end. Ha o sa tshikiwe mogala o tlhola o le ga se motshegare otlhe. But ha ke tsaya mogala ke go tshamekisa yane. I'm transferring energy from the mogala ke etse mo mogaleng. O tla mogala ga ntlo o tsamaya gore yane o tsamaya di wave yane. E nna ka re mogala wa tsamaya. But mogala ga o tsamaya o tsamaya di rota yane. That's a wave because I'm transferring energy from my hand into that rope. So one is a wave, that's a wave. Last example, so the whole is a chemical, that tuka. There are heat energy and light energy at the same time. So more than a flame. That's a wave. You want something is burning. A flame is a wave. I'm not a flame or a kappa and winds. It's just a wave, exists when something is burning. So that the wave is simply a shadow of our energy conversion. So similarly, I gave back to be how could I have a movie or what I could eat could we hire a movie? I thought I anything more than reverse. So I want to use that example here. So how do we electrons? We know what our voltage pushes our charge to flow around the circuit from negative to positive. So that those electrons, because they're carrying energy, it's simply energy conversion. It's more like energy conversion. Electrons flowing around the circuit, moving from one spot to the next, from one point to the next, carrying energy. They create a wave. Yala ka dikolo tse di moving in the motala ba go so le electron dira a wave it goes backwards. They create a wave it goes backwards. So when they flow from negative to positive, they create a wave wave again. It's a backwards. It's in this direction. And that wave is what you call current. What you call current. The electron flow from negative to positive. As they flow from positive to negative to positive, they create a wave and it goes backward. In which direction? Positive to negative. So why do we have current in the first place? We have current as a wave created by what? Created by flowing electrons. So current is a wave created by flowing electrons. If we never had electrons flowing, we would never have current. So current is a wave created by who? Created by flowing electrons. I think I emphasized it more than enough. Yeah. So examiners love this question. But yes, what is current? It's a wave created by flowing electrons. Um, um, in which direction does current flow? Current flows from positive to negative. And then if electrons flow from positive to negative, current don't know that right? It's not from positive to negative. So current flows from positive to a negative. So don't ever forget that. By random exam, who's about true or false? Electrons. Which of the following is true? Electrons flow from negative to positive. Current then flows from positive to negative. So don't ever forget that exam. And that way, if you're current, you know, then the measure this instrument, they're going to get amps, the king diameter, and this is going to get amps. Yeah. Libukani ukuthi zilikwaliwa so but I really like to, especially with the pure science, but I really like to go more pure. However, about current it's a wave created by flowing electrons flowing from positive to negative. Just by the ratio, current flows from positive direction to negative. Some books will tell you current is a positive wave. Yeah, positive wave. But current flows from the positive side. But what about current? It's a positive wave. So don't get me surprised. Don't be surprised how giant Bugadira. Here they charge flowing from negative to positive, and it's negatively charged. Some books don't charge. It is a negative wave. But it originates from the negative side. Happen charge is negatively charged. So don't be surprised by the game of gravity wave. Mhm. So I've introduced you guys to current. And ideal current. Currently, it is measured by an instrument, the Helayaga voltmeter. It's very important. It's going to be very important which parameters are measured. This one is measured using an ammeter. This one is measured using a voltmeter. This one is calculated, no instrument. This one is calculated, no instrument. Yeah. So the last parameter we're going to discuss is more like power. So with power, yes, our electrons, our charges carrying energy is going to do some work. Electrons are going to do some energy. Before you have power, as electrons flow around, we have this appliance. This is the appliance that is going to be doing work in our illustration here. So electrons as they pass here, they're going to dump energy here, and then they're going to emit energy. They're going to emit light. So there is a work. Work is being done here. Yeah, work. The ability to do work. And again, energy. Energy, the ability to do work. So this energy here is going to do some work here. And the way that I'm thinking, the lighting work. Yeah. So the way that I'm lighting. Again, it's what energy is the ability to do work. So what type of work is happening here is it's lighting. So some work is being done here done by who? Done by electrons. Work is being done by energy carried by electrons. Yeah. Mm. So okay. Because I agree what I said before this and give work energy. So the last parameter that we discussed is the power. So, Mobotshelong, it doesn't only matter for with the relative. It also matters for with the relative. Mana kwenye kalakala. Se khanyela with the relative. Kon be nanga of us kai. Haka go shoro ke tlala batla lunch. Abuona le bomme ba di two ba ka go apela lunch. O mongwe ba go apela lunch e monate. mme a go tsaya 6 hours go ya apara. O bongwe ba go apara lunch e monate le one, mme ba tsaya 30 minutes go ya apara. Wa go hira mang ga batla moapei, wa go hira le go tsana go e nyenyane, botlhe ba itse go apara ba dilo di monate, mme wa go hira o feng o e le gore mo tsana go e nyenyane go apara dilo di monate go na le go tsana go teng. So that's what we call power. Power ke gore o dira tiro mo nakong e kana kang. Power is the amount of work done per time. Ke gore o dira tiro mo nakong e kana kang. E seng ga gore o dira tiro, o dirile tiro eo, yes, but mo nakong e kana kang. Bontsi ba rona tlhane tse di bua gore hey, BMW powerful go na le ka next tlhaetse o le raya gore o rora ga ditaboga tsotlhe fa gote a di tswe mo magarapedi ya go tsena ko phalape. BMW le Ranex tsotlhe di ya go goroga, tiro ya go tsamaya yotlhe di ya go e dira. But ke efeng ya go dira tiro mo nakong e nyane ya gorogang pele, ke yone ya go dirang tiro eo mo nakong e khutshwane. It is powerful. This engine is powerful, this vehicle is powerful. O rela gona gore ya go cover distance e ntsi mo nakong e khutshwane. So power ke kganya gore dirile tiro e kana kang mo nakong e kana kang. The amount of work done per time. Yeah. So power it is measured in watts. Yeah, watt is simply homogeneous power ke di watts. I say mo ke work done. Power is measured in watts. This is watts. This one is work done. So power equals to work done over time. So one watt is simply energy per time. Is simply 1 joule per second. And motor being like I say, time is always used in seconds. So power is 1 joule, a joule per second. That's what we mean by power. What else can I mention? Power. So mo go ke na go bua ka tsa ke go bua se dira di formulara. Mo go ke na go go bua ka tsa ke go bua se dira di formulara. Power equals to amount of energy conversion per time. One thing that I would like to yeah, I calculate the power. I was amount of energy that we divide in seconds. One thing that I would like to mention more power is a rate. Power is a rate. Some of these easy questions may examine, but which of the following are rates? How about there something is a rate? More examine, more physics is that thing per time? Anything per time is a rate. Yeah. So power is rate than per time. Anything that is per time is a rate. How about the one salary ya 50,000 ka kgwedi, wena gore ke salary ya gago per month. Monthly ke nako. So that's a rate. Salary per month, that's a rate. Ha ke gore ke re kolo ya go ya accelerate ka bokae. Acceleration e melela ka bo acceleration ke meters squared per second. Again, meters per second squared. Meters per second per second. Fact that we mentioned per second, then acceleration is a rate. Speed equals to distance over time. Speed equals to distance per time. So speed, velocity, those things are rates. Anything per rate. So even if the exam goes very stupid, or per time. It was already, is this a rate? Yes, it's a rate. Anything per time, anything per time, it's a rate. When I'm examining out already, each of the following are rates. Just look for salary is per time. Mm. So, yo go ntla la itse ke potso ya physics le mme tse ba ratang mo exameng gore di tlhano gore a mme rate la itse gore go toka gore per time. So, power is a rate. Ka ke le botse difumana tse different tsa power ha re ntse re tswela le topic. So, ne ke batla gore by introducing the topic le itse di-definitions tsa gore what is electricity is the flow of electrons flowing around the circuit. What is flowing is electrons, and what's pushing these electrons to flow is the potential difference. This attraction between the negative and positive is what attracts the electron from the negative side to positive side, and that attraction is measured in volts. It's what we call the potential difference. And a group is a group of electrons flowing. We call them charge, and that charge creates a wave. A wave e le goreng ke yone ke current. It flows counter wise to the flow of electrons. Yeah, I want to know the directions of the flow. About how we talk about these electrons, this charge doesn't flow empty-handed. It's carrying energy, and then energy what is going to do work in our circuit. And then it matters also what this energy conversion in how much time, and that is what we call power. Yeah. So thank you so much for your attention. Get the rap listen.
46 minutes.
46 minutes. 46 minutes. Like it will go 50. You will learn 7.5. Like I get out of mention this in a speed differ. The mention is in a speed. The bar goes on. The bar goes on. This thing we call filament. This filament. We directly mention a filament. We do like our calculator. What can we say? 1, 2, 3, 4, 5. Yeah. The gas was our concept in here. Like it pure effectively. Finally, number 6. Number 6. More than resistance. Resistance. Yeah, like it and the same. For the lemon one resistance. Resistance is measured in ohms. Is measured in ohms. So what is resistance? Resistance is like it's inhibition to flow of electrons. So these electrons they don't just flow volume profile, they don't just flow easily around the circuit. They experience a resistance. They are so called. I don't know why they are so called. Depending on where it is. So electrons experience inhibition to flow, and that inhibition to flow of electricity is what we call resistance. It is measured in ohms. So abbreviated as R, and then the symbol again the omega sign. So resistance agar energy le charge. There's no any instrument that measures resistance. We calculate resistance. We calculate resistance. Scoring kind of an idea about resistance. Kanari buanda sa magobi. How can I wire it sign? How can I wire it sign? How can I wire it sign? I would not wire From common sense, the electron di a go sokola go tsamaya mo wiring efe. Ke tsela e tshesane ga go pitlagana le ba ntse gore tsena mo tseleng. Tsela e kima tsena di phuthologile mo tseleng. So wire e tshesane go na le pitlagano e ntsi mo teng. Di-electron di a go tsamaya di kgotlagane di sokola go floor. That's what do you mean by resistance? Wire e tshesane just got a high resistance. Re rana gore pitlagano eno ke yone resistance. Tshokolo ya go floor ke yone resistance. wire e kima go na le space se ntsi dilo tse di tsamaya sentle di phuthulogile ra o nga tsamaya go nga tsamaya renko, so there's low resistance ke yone tsela e tshwana le wire e kima e tshwana le tsela e isang ko diheleng, e tshwana tsela e isang ko diheleng, tsela e isang ko tatlhegong e tsamaya mo mo teng ga ena resistance, so tsela e isang ko tatlhegong bothata le mangwe le gone gore megala e me kima e isa ko tatlhegong gantsi cause e ira gore di fele di išwa because of that low resistance. It becomes a disadvantage. So megala e me kima e dira a root of low resistance. Megala e necessary thin wires with a very high resistance. Yeah. So this is what we call resistance. So mogala o na mo sense o na le resistance e ko godimo. Even when you bring in an insulator, agree, an insulator is something that doesn't conduct electricity. So insulators have got the highest or infinity resistance. Electrons won't flow through an insulator. So insulator will bring an end to the flow of electrons. So emitere go ene omega ga ba go botsa mo exameng gore highly conductors and insulators, which one has got the highest resistance? Is insulators have got the highest resistance. Yeah. So with resistance, you are simply trying to bring an end. You are trying to stop electrons from flowing by creating that route in order is narrow. Yeah. So la itse ba ba tsenang kereke kana ba ba le Bible ba tla ba utlwa go te Jesu ke alpha le omega. So utlwa ade Jesu ke alpha le omega. Ha go te Jesu ke alpha le omega go twa go te Jesu ke tshimologo. Alpha go twa go te tshimologo, the genesis. Omega go twa go te the end, tshimologo le bokhutlo, right? So resistance is trying to bring an end to flow of electrons. It's trying to bring an end, the omega, it's trying to bring an end to flow of electrons. That's why it is measured in omega, because omega are already the end, right? Omega are already the end. Resistance is trying to bring an end to stop flow of electrons, to bring an end to this flow of electrons. Yeah, ebile ha ke di yalo ke go botse bontle gore what caused the electrons to flow around the gate is a voltage. The potential difference is what caused the electrons to flow around the gate. So o ka lemoga gore batho ba science ba ile ba jalesetsa voltage. Agree voltage go ne similar, like it brings the genesis to flow of electrons. So I tlhola gore maybe a ne re ka batla ebile gambe ne re ka change the units tse di measurang voltage. Go be re measure voltage ka alpha. Go be re instead of re 20 volts go re 20 alpha, because go push the voltage brings the beginning. It is what causes electrons to flow. So voltage is the beginning of electricity, the genesis, but the end of electricity, the phenomenon that is trying to bring an end to a flow of electrons, that is trying to stop this electricity from happening, is what you call resistance. So it is calculated in ohms, this resistance. Neke, phenomenon at level 6, we had to discuss it to close off this introduction part. Neke, light, but again, bulb. It is made up of these small wires. So what it is when you bulb in this wire, what it when you filament. Our olden bulbs, if like our motive when you filament. The filament is very thin. Because it is very thin, it has got a very high resistance. It has got a very high resistance. Barata makes the note about which metal is used to make filaments. Tungsten is an alloy. So it's already tungsten is used to make tungsten. So it's already tungsten. Yeah, it is an alloy that is used to make filaments. It's very thin. So electrons highly traditional energy and this filament is so thin that it can only allow electrons to flow around. Electron is together bank energy. So how it's another pattern in but the whole seven of it. How full seven energy. So that's how you get this lighting. The filaments start glowing. Filament they are glowing because of that energy that is being dropped around it, and then also another that lighting that happens. Mm. Ba rata go tsweng ka tsa go tswalela pele before ke dira ke tswala ko go telele yanong ke ne ke dire part two. This is part one of electricity. Before we dira part two, go tla gore ba rata go tsweng ba rata go botsa gore tungsten is a metal filament. It's a solid. It's a solid. Um, ba rata go botsa gore tungsten as an alloy. Why these are tungsten? Why these are tungsten? Hydrogen filament. Why tungsten is used to make filaments? About A, because tungsten has got a high melting point. Because it has got a high melting point. Which is true about tungsten. Tungsten has got a high melting point. About B, because it has a high boiling point. Because it has a high boiling point. Yes, tungsten has got a high boiling point. It has got also a high melting point. So ke mo ka ba buile di answer tse pedi mo ile di answer ba ntse di answer tse pedi mo multiple choice. Ba batla ke tlhophenyana so ke botsa a examiner wa tsena. Go bolele. Tungsten is a solid. So the only thing you are worried ka highlighting can this tungsten melt? Agree it's a solid. It can only melt before you even think of boiling. So tungsten is used as a filament because it has got a high melting point. Again, at this point, it is still a solid. So the only thing you can worry about what can this tungsten melt before you can think of boiling. You would only be worried of boiling if tungsten was a liquid. So it hasn't yet melted. It is still a solid. So you can only be worried for it can melt. So even though another high boiling point, another high melting point, but at this particular juncture, you're only worried about it melting. So as you go along, the exam questions and it's going to make your life very easy. The more what am I want to exam ya bona motlhofo mo go yena. There's no one watching that class yaka. Ke ba go ntha exam which is exam ya thata because dipotso tsotlhe ha sa ke fetsa go discussa from here ra ka dira di formula tsa motlakase gore di tlile ya ba di ra di dira ka mmogo e be la go di memorize. Then the tla ke tsa part ya motlakase la every step I'm going to keep on showing you gore go tswa mo exameng. And by the time I have to begin, I'll give you a combination of questions. Se tla go bontsha gore mo examiner wa ka ne ka tsela e ntseng jang. How I follow my sessions, exam is going to be over. Thank you for your attention.